You ever stop and think, what if the universe is just way stranger than we can possibly imagine? What if the basic rules of reality, time and space, aren't what they seem at all? It's a wild thought, right? Well, that's exactly the question a young patent clerk named Albert Einstein started asking more than 100 years ago. And his curiosity? Well, it was about to change everything.
And to help us wrap our heads around all this, we're looking to one of the greats, Stephen Hawking, and his incredible book, The Universe in a Nutshell. So we're going to dive into how Einstein basically turned our understanding of the cosmos completely upside down. It all started with this one really stubborn puzzle, a mystery that just wouldn't go away.
See, before Einstein came along, physics was in big trouble, and it was all because of light. Scientists kept finding evidence that just didn't make sense. It seemed to break every rule they thought they knew about how the universe worked.
Okay, so here was the big contradiction. The thing that was driving physicists crazy. For ages, everyone figured light had to travel through something, right? They called this invisible stuff the ether. And it seems logical. If you're moving towards a light source through this ether, the light should seem faster. Kind of like if you run towards someone throwing a ball at you, the ball gets to you quicker. Makes sense. But here's the thing. The experiment showed something totally impossible. No matter how fast you were going or in what direction, the speed of light was always the same. It was just stubbornly, maddeningly constant.
And the final nail in the coffin for this whole ether idea came from this one really brilliant experiment. It was called the Michelson-Morley experiment, and it was designed to do one thing: detect the Earth moving through the ether. They figured as the Earth orbits the Sun, they'd get different readings. But you know what they found? Nothing. Absolutely nothing. No change. The speed of light just refused to budge. Physics had hit a brick wall. It was officially stuck. And this is where our guy, a young and totally unknown Albert Einstein, steps onto the scene. See, instead of trying to patch up the old, broken rules, he decided to do something way more radical. He proposed a brand new one, and it was breathtakingly simple. So in 1905, Einstein drops his theory of special relativity. And what he does is genius. He takes that piece of evidence that baffled everyone else, and he makes it the cornerstone of his entire theory. He basically said, okay, let's just accept this as true. What if the speed of light is the one thing in the universe that never changes? But for that to work, something else has to give. And that something else? Well, it was space and time themselves. He said they must be flexible. They have to stretch and shrink depending on how you're moving. And this quote from him really gets to the heart of the matter. It's like a principle of cosmic democracy. It means that no matter who you are or how fast you're flying through space, the laws of physics, including that constant speed of light, have to look exactly the same for you as they do for everybody else. And let me tell you, the consequences of that one simple idea, they are absolutely mind-bending.
To really get a handle on just how weird this gets, we have to talk about the famous twins paradox. So, picture this. You've got two identical twins. One of them stays home on a planet, just living their life. The other one, they jump into a super advanced spaceship and just blast off, traveling at almost the speed of light.
Okay, so years later, the space-traveling twin comes back. And here's the crazy part. They're now younger than the twin who stayed behind. It's not a trick. For the person moving at that incredible speed, time itself, their personal clock literally ticked slower. And this isn't some science fiction story. It is a proven real-world consequence of how our universe works. Time isn't this fixed, absolute thing. It's relative. But wait, there's more. Einstein's theory didn't just mess with our concept of time. It uncovered this deep, hidden connection between two things we always thought were completely separate: energy and matter. And that connection led to this. Yep, the most famous equation in all of history. It was just sort of tucked away inside his theory of special relativity. It looks so simple, just a few letters, but its implications were about to change the world forever. So what does it actually mean? Well, E equals mc squared tells us that mass and energy are basically the same thing, just two different forms of it. They're interchangeable. And the equation gives us the conversion rate. It says that a tiny, tiny amount of mass, that's the m, can be turned into a truly enormous amount of energy, that's the E. And why? Because you multiply it by the speed of light squared, and that is just a ridiculously huge number.
And the real-world consequences of that simple idea, wow, they are staggering. This is the secret sauce behind both the immense power we harness in nuclear reactors and the terrifying destructive force of an atomic bomb. Both of them work by converting a little bit of matter into a whole lot of energy, exactly like Einstein's equation said they would.
Okay, so Einstein had cracked the code on light and motion. Pretty amazing stuff. But there was still this one giant piece of the puzzle missing: gravity. Newton's laws had worked great for centuries, but they just didn't play nicely with this new, flexible, relativistic universe. Einstein knew his work wasn't done yet.
His big breakthrough came from what he called his happiest thought. It's a simple idea, really. He realized that if you're in a closed room, you can't tell the difference between feeling gravity pulling you down and feeling a rocket pushing you up. The forces are identical. And on the flip side, the feeling of being in free fall is exactly the same as floating weightless in deep space. This idea, the equivalence principle, was the key that unlocked everything. And this led Einstein to his next giant leap, a totally revolutionary conclusion. Gravity, he said, isn't a force at all. There's no invisible rope pulling things together. Instead, gravity is just the curvature of space-time itself. Heavy objects, like planets and stars, literally bend and warp the fabric of space and time around them. And other objects, they're just following those curves. The Earth isn't being pulled by the sun. It's just rolling along inside a deep dimple in space-time that the sun has created.
Now, this new theory, which he called general relativity, did way more than just explain gravity. It gave us a brand new picture of the entire universe, from how it began to where it's all going.
And one of the wildest predictions to come out of it was this: if heavy objects bend spacetime, then even light, which has no mass, should have to follow those curves. So light from a faraway star passing by our sun, for example, shouldn't travel in a perfectly straight line. It should actually bend. This was a prediction so out there, people just had to go and test it. And in 1919, they got their chance. During a total solar eclipse, with the sun's glare blocked out, astronomers took pictures of the stars right next to it. And what did they see? The stars weren't where they were supposed to be. Their light had been bent, just as Einstein predicted. The news went viral, 1919 style. The headlines were explosive. In an instant, Newton's universe was history, and Einstein's universe had arrived.
But maybe the biggest revelation of all was hidden right there in the math. The equations of general relativity pointed to a universe that was alive, that was dynamic. It couldn't just sit still. The math showed it must have had a beginning, a single explosive moment we now call the Big Bang, and that it's been expanding ever since, with all the galaxies flying away from each other on this stretching fabric of space-time. So think about that. Starting from just one weird, stubborn fact about the speed of light, Einstein completely unraveled our understanding of space, time, energy, and gravity. He showed us a universe that was so much stranger and, frankly, so much more beautiful than anyone had ever dared to imagine. He really did give us the universe in a nutshell. Which, of course, leaves us with the biggest question of all: what other mind-blowing truths are still out there, just waiting for us to discover them?